In this video, I'm going to show you how to generate a spoofed ADS-B signal and combine it together with real ADS-B signals that are received over the air. Now, I'd like to emphasize that the spoof signal is not going to be transmitted over the air. We don't want to do that for obvious reasons. We're going to mix the spoofed and real signals together using a cabled setup and a power combiner. So I'm going to explain all the hardware we're going to be using and show you how to hook everything up and how to set up the software on the GNU Radio virtual machine that we set up in previous videos. So let's go ahead and get started going through the hardware. The first device we're going to look at is a RTL-SDR dongle. This is what we're going to use to receive the ADS-B signals, and this is a particular kind of RTL-SDR dongle that has a device in it called a bias T. And the reason for that will become clear once I explain the next device, which is a low noise amplifier. This is going to amplify the signals that we receive over the air, and it's going to allow us to receive weaker signals than we might have been able to otherwise. Now, LNAs typically are powered using a DC voltage, and this particular LNA can be powered using 5-volt DC that's output by the bias T on the RTL-SDR dongle. Now, this is a wideband LNA that covers a wide frequency range, but importantly, it covers the ADS-B band that we're interested in. The next device we'll look at is a ADS-B filter. This simply rejects all frequencies outside of the ADS-B band that we're interested in, and this will prevent any nearby in frequency kind of interfering signals from overwhelming our receive signal. And the antenna we'll use is just a simple monopole. Now, for transmitting, we're going to use a particular software-defined radio called a HackRF. This connects to the laptop using USB. And now the signals generated by this device are going to be quite a bit stronger than the signals we receive over the air. So we're going to attenuate the signals using a device called an attenuator. This is just a 30 dB attenuator that will connect directly to this port and in on the HackRF. Now, to combine the over-the-air signals with the spoof signal, we're going to use this device. This is a power combiner. It's just going to combine our two signals together into one and output them to the RTL-SDR dongle for reception. And of course, we'll have a variety of SMA cables for hooking together all the RF components. So let's go ahead and get started hooking everything up. Take your RTL-SDR dongle and connect it to a USB extension cable. This is just for strain relief so that you don't risk damaging a USB port by connecting the dongle directly into one. Let's go ahead and connect that. Next, take a kind of short SMA cable and connect it to the dongle. Then connect the other end of this cable to the power combiner. Connect it to the port that's labeled S. All right, next we'll hook up the LNA and the filter and the antenna. So using a kind of a long SMA cable, this one's about a little over a foot, go ahead and connect one end of this to the power splitter. Then hook the other end of this cable to the port on the LNA that's labeled out plus 5-volt. This is important. You want to ensure you're connecting to the out port because this is the port that will accept the DC voltage from the bias T in the dongle. So go ahead and hook that to out. Next, connect the filter to the other port on the LNA. And then hook the antenna to the filter. Next, we'll connect the HackRF. So first connect the attenuator to the port labeled ANT-in on the HackRF. And we're also going to connect this device. This is called a DC block. All this does is ensure that the DC voltage output from the dongle doesn't reach this HackRF. So just daisy chain that onto the attenuator. Now, using an SMA cable, connect the HackRF to the power combiner. Now I'm going to make sure that the antenna is kind of close to this window that I'm sitting next to, and that's just to make sure that we get, kind of a reasonably clear view of the sky. So you'll want to do the same, of course, or you could just go outside. Either way, whatever's convenient for you. So now we're ready to connect the RTL-SDR dongle to the laptop. So connect this to a spare USB port on the laptop. Now connect the HackRF to a spare USB port on the laptop. All right, now all of our hardware is set up and we're ready to switch over to the virtual machine, and I'll show you how to set up the software.
Now that we've attached the hardware required to spoof and receive ADS-B signals, let's go ahead and configure the software. So go ahead and launch the GNU Radio virtual machine that we configured in previous videos. I'm going to pull mine up, and I'm going to go ahead and full screen it by pressing Control F. So the first thing we need to do is pass through the RTL-SDR dongle and the HackRF device into the virtual machine so that we can access it. And so to do that, move your mouse cursor down to the bottom of the screen to pull up the VirtualBox flyout menu and click on Devices, and then click on USB, and then click on Realtek RTL, and then so do the same thing again, click on Devices and USB, and confirm that there is a check mark next to your Realtek RTL entry in this menu here. And if there is, go ahead and click on the Great Scott Gadgets HackRF 1. And now let's confirm that we've attached by clicking Devices again, clicking USB one more time, and confirming that there are check marks next to both devices, the HackRF 1 and the Realtek RTL. Now, if you have any difficulties at this step where the check marks just aren't occurring, try unplugging and replugging in the dongle and the HackRF. In my experience, I always had to plug in the dongle first and then the HackRF, and likewise I had to click on the Realtek RTL entry in this USB menu first and then the HackRF entry. So you might have to experiment a bit, but the point is you need to get to the point where you have check marks next to both of these devices. All right, so once the devices are connected, we need to make one configuration update to the virtual machine. And the reason is that we're going to be installing a custom GNU radio module, so we need to make sure that the machine can actually execute it. So to do that, go ahead and open a terminal, click on Terminator here, and type gedit space dot pam, P-A-M, underscore environment, just like that, and then press enter. And now the text you're going to want to enter in the screen that comes up is capital Python path, all one word, space, default, all uppercase, and then equals /USR /local /lib /python 3 / dist, D-I-S-T, dash, packages, colon, Python, or excuse me, colon, and then a $, and Python path. And then once I'll leave that up for a second so you can take a look at it. And I'll also paste this line in the description of the video, so you can just copy and paste it if you want. Once you've done this, go ahead and click Save, and then close this text editor. And so what that has done is created an environment variable that makes it so that when we install our custom module, we can the Python code is actually accessible. So to make this change active, we need to log out and log back in of this user account. So in the top right of your screen, click the down arrow, and then click on Power Off Log Out, and then click on Log Out, and once again click on Log Out, and then log in again. And now to confirm that the environment variable that we set is actually set, go ahead and open a terminal and type env space and then a pipe and then grep and then -I and then Python. I'll leave it up for a second, then press enter. And what you should see is this Python path equals this entry here. So if you can see that, then you have set up your environment variable correctly. So the next thing we want to do is download the software that we'll use to receive the ADS-B signals, as well as the software to spoof them. So go ahead and open a Firefox window and go to Google. And we're going to go to my GitHub repository because that's where the code is hosted at the moment. So type GitHub and then my name, which is Terry, T-E-R-Y, space Ferret, F-E-R-R-E-T-T, just like that. Then press enter. And then hit the first link that comes up. And then click on the GR-ADSB out link here. And I'm going to highlight the direct link to this website, just so if you want, you can just type this URL directly into your URL bar. So once you're here, click on the green code button, and then click on HTTPS. Highlight the link in the box that appears and copy it. Right-click and copy. Then come back over to your terminal and type git clone, and then right-click to paste the link we just copied, just like that. And then press enter. All right, so that checked out the GR-ADSB out module. So type cd gr-ADSB out, like this. Press enter. And now we'll make a directory to build the code. So type mkdir, make dir, and then build, B-U-I-L-D, and press enter. And then cd into build, like this. And now type cmake space .. / and press enter. Now type make and press enter. And then finally type sudo, S-U-D-O, space make space install and press enter. And what that did is installed the module that we just built. So that is set up. Next, we need to download the receiver software. So type cd space tilde, like that. Press enter. That just takes us back to the top of your home directory. And then come back over to your browser window. And if you still have this page open with GR-ADSB out, just come up here in the top left and click on my name, T. Ferret. And then go to this link here, dump 1090. Click on that. And click on the green code button and HTTPS and copy the link like we did for the other software. Then come back to your terminal and type git clone and paste, right click to paste in the link that we just copied. All right, and then cd into the new directory dump 1090 and type make. All right, so let's test this by running the dump 1090 software to see if we can receive ADS-B signals. So type /dump 1090 space dash dash interactive space dash dash net, and then press enter. And if there are planes nearby, then you should start seeing entries pop up in this table. So if you're seeing entries, then you're receiving, your ADS-B reception is working. And it looks like I'm getting a lot of entries here, probably because I'm close to LAX airport. So now what we want to do is inject some of our own spoofing signals into this stream. So with your mouse cursor, come up here to the top left corner and click on the icon GNU Radio Companion here. Go ahead and full screen this. And click on this button, which is the open existing flow graph. And then click on GRADSB out, examples, and then HackRF.grc. This is the GNU radio flow graph that we're going to use to create and inject our spoofed signal, ADS-B signal. So go ahead and click this play button here, which is the execute flow graph button. Go ahead and click OK for this message that comes up. Now, what will happen is you'll get a new window that with this title HackRF TX flow graph, and it'll have one GUI control on it labeled gain. What this does is controls the output power that you're transmitting with. It starts at the lowest possible setting, which is 0, and then what we're going to do is slowly increase it until we actually see our spoofed signal come up. So click on your terminal again just to bring the dump 1090 window into focus. And then what we're going to do is we're going to increase this gain value here until we start to see an entry from our spoof signal over here in the dump 1090 software. Now I've named the flight for our spoofer ROFL12, ROFL12. So once the gain reaches a certain point, we should see that appear here. So I'm going to go ahead and start increasing the gain by clicking this up arrow here. You should start to see signal once you get up to about 20 dB, maybe a little bit higher. And there it is. ROFL12 with the altitude and latitude and longitude that I configured for the spoofer. I set it to a location that's kind of close to where I am, just so it's easy to find on a map. But I'll show you how to set these latitude and longitude values. But for now, let's take a look at all this on a map. So go ahead and go back to Firefox and open a new tab and then type localhost :8080, localhost 8080, and press enter. This is going to bring up the map view of the output of dump 1090. Now remember that you have to center the map over what you want to look at. Since I'm in Southern California near LAX airport, I'm going to center the map myself over that location. And we can already see a bunch of planes being drawn on the map. Excuse me. I'm going to zoom in on it. So here it is. According to dump 1090, there are 8 planes on the screen. We can see, yeah, by my count, that is definitely 8. So let's go ahead and click on one of them. And when we click on it, what we should see appear on the right column is some information about this flight. So this is flight AAL 136. When you select a particular plane, you'll get a green circle here instead of the red circles over all the other planes. So this is a real signal. Let's take a look at our spoofer signal. And for the purpose of this demonstration, I kind of know where I set it. So it's this plane here that's over Redondo Beach. I'm going to go ahead and click on that. And as you can see, this is our Raffle 12 flight. Right, and this is how to inject a spoofer into an ADS-B receiver stream. Now, before we finish, let me go ahead and show you very quickly how to set the latitude and longitude for your spoofer. So go ahead and come back to your GNU radio window, and then double click on this block here that's called ADS-B position source. Once you double click it, you'll get a new window that has a bunch of entries on it. And if you want to set the latitude and longitude for your spoofer, you enter them here in these fields, latitude and longitude, in values of decimal degrees. So you can also change the name of the flight as well. Hit OK on this window. If you want to change the name of the flight, double click on this ADS-B ident source, and you can set the call sign here. Right, and that is how to inject a spoofer into an ADS-B stream. Thanks.